What does each part of f of x mean? In this lesson, you will learn how to interpret function notation by looking at the language of f of x. Let's review. Once we've determined whether or not a relation is a function, and this one is because each input only has one output, we replace y with function notation, and the most common form of function notation is f of x. Well, when using function notation, there are two misconceptions that we need to clarify. Number one, many students think that f of x means f times x, but this is not the case. F of x does not mean f times x. Look at the equation below. F of 3 looks exactly like 2 times 3, which makes it really confusing, but you have to remember that this is not the same thing. F of 3 is just showing us that f of 3 is our output when 3 is my input. The second misunderstanding is that f of x is the only way that function notation is shown. But f of x is not the only format for function notation. We can use g of x, p of q, h of g, d of t. Any combination of variables works. The first variable is defining the function or giving it a name, and the second variable in the parentheses is telling you which variable is your input value. So if f of x doesn't mean f times x, what does it mean? Well, if you see f of x, or any form of it, it means that we have identified this relation as a function. But f of x on its own means that f of x is my output when x is my input. F of x is simply taking the place of y as our output. When you have a function that relates directly to a problem, the variables we use in our function notation help us identify the relationship between the numbers, which ultimately helps us understand our function's meaning. For example, we're used to seeing c equals 2 pi r, which is the formula for circumference, where we know that the circumference's value depends on my radius's measurement. But this is actually a function, because for each input value, I only get one output value. And if we know that this is a function, we can use function notation by naming it c of r, which can also be read as c as a function of r, which just means that the circumference depends on my radius, just like it does when it's in c equals 2 pi r format. Again, both formats of the equation have the same relationships between the number, but when we use c of r, we're just showing that we've determined that it's a function. Also, I can look at distance equals rate times time, where the distance I travel depends on the amount of time I'm traveling. If I'm looking at d equals r times t, and I add a constant value for the rate, let's say 15 miles per hour, and then I plug in input values, I can see that this is a function because each input only has one output. And since it's a function, I will use function notation, and I'll make it d of t, because the output, the distance, depends on my input, the amount of time. Again, we are still working with the same relationship, just in a different format. So what does c of r mean again? Well, c of r equals 2 pi r just means that the circumference's value depends on the value of the radius, where the radius is my input, and that's what determines my circumference, which is my output. And what about d of t? Well, d of t equals rate times time means that the distance traveled depends on the amount of time we spent traveling, where my input is the time, and that's what determines my distance traveled, which is my output. In this lesson, you have learned how to interpret function notation by looking at the language of f of x.